Okay, so now let's talk about the different kinds of fossil fuels. So coal is one of the big three. It's a hard, blackish substance formed from woody organic matter compressed into a dense, solid carbon structure. So you know what coal looks like. It looks like a hard black rock. Um, the more coal is compressed, the denser its carbon content and the greater its energy content per unit volume. So basically, coal is normally made when water is squeezed out of material as temperature and pressure increase over time and little decomposition takes place. So here's an ancient forest, something died, and then over time, pressure and heat is applied to it, and that's what adds the energy content. So peat is a precursor to coal, and then we have these different kinds of coal. The more heat and the more pressure, the more energy is stored in the bonds in the coal, so it has more energy content per volume. Coal is extracted normally through strip mining, subsurface mining, and mountaintop removal. So those are three different strategies, which we'll talk about later, of how to remove coal. Mountaintop removal is literally blasting away the entire mountaintop to get to a lot of coal. Oil, or crude oil, is defined as natural or unrefined oil extracted from the ground. It's a thick blackish liquid that consists of a mix of many types of hydrocarbon molecules, which are super long chains of just carbon surrounded by hydrogens, and that's what coal is, or that's what oil is. Natural gas is a gas containing primarily of methane and other volatile hydrocarbons. Volatile meaning they will explode, which is how we get energy from them when we combust them. So methane is mostly methane. Sorry, natural gas is mostly methane. And then the word petroleum normally refers to oil, but it can also refer to both oil and natural gas together as one group. Oil and gas are derived from marine plankton that died, sank to the sea bottom, became buried, and transformed by heat, time, and pressure. And these eventually settle under impermeable rock formations, which must be drilled through before oil and gas can be accessed. So they're stored under rocks, and so that's what we have to drill for them through the rocks. All right, now we're going to talk about the unconventional oil fossil fuels. They are oil sands, oil shale, and methane hydrate. The first one is oil sands, and they're a mixture of moist sand and clay containing 1 to 2% bitumen, which is a thick and heavy form of petroleum. And so bitumen must be chemically refined to create synthetic crude oil. So that's how we can get crude oil from the oil sands. And oil sands form when crude oil deposits are partially degraded by bacteria. So there was a crude oil deposit there, and then it was decayed a little bit, and it became an oil sands. Oil shale is the second kind of unconventional fossil fuel, and it is sedimentary rock filled with organic matter that can be processed into shale oil. It can be burned directly like coal, or it can be processed. So basically you can bake it in the presence of hydrogen in the absence of air, and you can get out liquid petroleum. So it can be used as coal or as petroleum. And this is found in areas where deposits were not buried enough to be subjected to enough heat and pressure to form oil. So it's like they could have been, but there wasn't enough heat and pressure to turn into oil. The third one is methane hydrate, which is an ice-like solid consisting of molecules of methane embedded in a crystal lattice of water molecules. So basically it's found in sediments in the Arctic and the ocean floor. And the reason for that is because it's only stable at a temperature and pressure condition found there. So that's what methane hydrate is. So those are the three: oil shale, methane hydrate, and oil sands. And the way that we know how much we're going to be extracted depends on economics. It's all about money. It's all people want to do is to make money. So the portions of fuel that are physically accessible to us are called technologically recoverable portions. Based on technology, we can get there. So that could increase as our technology increases, or it could, so that's why it's called technologically recoverable. As we uncover more technologies for finding and extracting oils, these portions increase. Then we have the economically recoverable portion of all the fossil fuels, which depends on the cost of extraction and the market prices. So basically, if it's going to cost more to get it out than it will to it's going to cost more to get it out than we will be able to make on it, then it's not economically recoverable because we won't make money on it. So that would change as the market price of fossil fuels go up and down. So how much you have to pay for it goes up and down. Then the two of them together are called proven recoverable reserves, are both technologically and economically recoverable. And so this one will improve as technology improves or as market prices of the fuel rise, and it will decrease as fuel deposits are depleted by extraction or as market prices fail. Now that would mean that extraction would be unprofitable, so it would no longer be proven recoverable. Okay, so we get these things out, and then we can't just burn crude oil in our cars. That wouldn't work very well. Our car engines are not built for that. So we have to go through a process of refinery. So crude oil is a mixture of hundreds of hydrocarbons, really long chains of carbon surrounded by hydrogen, and must undergo refining, a process that separates the molecules by size. So basically, we can create many different types of petroleum products by separating its various components. And during refining, hydrocarbons are separated by size and are chemically transformed to create specialized fuels for heating, cooking, and transportation, and as well as used to create lubricating oils, asphalts, and the precursors of plastics and other petrochemical products. So plastics are made of petroleum as well. So basically, we boil them and remove them at different temperatures. So butane is a type of gasoline. It is type of oil. It's what's found in like lighters. Gasoline is what we put in our cars. Kerosene is used for lamps a lot. Diesel is used for trucks. Down here is lubricating oil and fuel oil. And then there's some residue left out. If you live in El Segundo or if I've been driven through there, there's the Chevron oil refinery, and that's what is happening there. Then the separated products of refining, so after we separate them, they are specialized fuels for heating, cooking, transportation, and are used to make, I already said that. So gasoline is most of the typical output. Then we get diesel and heating oil, jet fuel, liquefied petroleum gases, heavy fuel oil, and other. And fossil fuels have many, many uses. The amount of a fossil fuel that nations extract and consumes depends on its size and level of industrialization. Each fossil fuel has its own mix of uses. Coal, for example, is primarily used for electricity generation. Historically, it was used to heat homes and cook food, but now it is used for, then later steam engines. It's now for electricity generation. So coal around the world, coal, oil, and natural gas around the world are used differently. So the US doesn't use as much coal as China or India, but it uses much more oil and much more natural gas. So if there's a factory that is using coal as its fuel, it uses coal combustion to turn water to steam, which turns turbines to produce electricity. So what happens here is coal is pulverized and blown into furnace, sorry. So broken up into pieces, goes into a furnace. Heat from combustion boils water, so then we light the coal on fire and it burns. It's like charcoal if you ever have a barbecue. Then there's water. The heat boils the water. Then the water releases steam as water vapor evaporates. And the steam turns a turbine, which is like a windmill or a water mill, which rotates magnets past copper coils in a generator, creating electricity. So basically the power from the turbine creates electricity in here. Then electricity is distributed to consumers by transmission lines. So when you have one of these to charge your computer, it's coming from this process. Steam is cooled and returned as water to furnace. So water is reused in this process. It's not damaged. Pollutants from combustion are filtered, and toxic ash residue is taken to hazardous waste landfills. So that's how we get energy from burning coal. Natural gas is used for electricity generation, heat, and cooking. Most homes have two energy sources, electricity and gas. So if you have a stove that has flames that come out of it, that's natural gas. Most heaters, water heaters, those all use natural gas. My house actually doesn't. It's all electricity. But and then petroleum products are used as fuel for vehicles, and petroleum products are found in many household items. So it says to look around and see all the ways in which petroleum products affect your life. So like CDs and DVDs, you probably don't have too many of those, but when I was your age, I had CDs all around me. They always have petroleum in them. A jacket, light switch, parts of a bike, picture frame, shower head, shower curtain, everything that's plastic has been made from petroleum. Um, So this shouldn't be news to you, but we are depleting our fossil fuel reserves because it is non-renewable and we are using them as much as we want to. The total available amount on Earth declines as we use them. So we have what's called the reserves to production ratio, or how much there is to be found anywhere, like how much there is reserved in the Earth, and by how much we are using each year. So it's the R to P ratio. The current estimate of oil reserves is 1.7 trillion barrels, and the rate of production is 32 billion per year. So that estimates that if you do 1.7 trillion left divided by 32 billion, which is how much we use a year, that we have 53 years of oil left. That's not that much. It might seem like a lot, but 53 years ago was in the 60s. And we've been using this stuff for a lot longer than that. Like, that's how long. Some of your parents might be that old, for sure your grandparents, like that's not that long ago, and that is not that far away until we would run out, if that's how much is left. So natural gas reserves are estimated to last 54 more years, whereas coal's is 110. And the actual amount of years we have left would change if our demand, production, or known reserve level changes. So basically, if we are better at reducing our amounts, that will last longer. If we have, if we enhance efficiency, like get more energy efficient and don't have to use as much, that would make it last longer. But if our demand and our production continues to rise, they might last for a less amount of time. So new technologies like this thing called hydraulic fracturing, also known as fracking, allows us to access tight oil confined in or near shale, increasing our reserve levels. Tight oil is conventional oil held tightly in or near shale. So basically it's oil that's been trapped in a way that we couldn't normally get to it before, but now we can. So now we have increased our reserves due to fracking, which we'll talk about in the next lesson. And eventually extraction of any non-renewable resource will reach a peak and then decline. And so if our demands hold steady or increase when this happens, our shortages are really likely. This scenario is called peak oil with petroleum because it is likely to occur in the near future.